Hello everyone, welcome to today's session. Today we are going to discuss a couple of questions from exercise 4a of your chapter number 4 refraction at plane surfaces from concise textbook physics. In the previous sessions we have discussed question number 1 to 10. If you have not watched the video, please watch those videos so that you may have a better understanding of the concept and the topic discussed over there. Today we are going to discuss question number 11 to 20. We start with question number 11. Look at the screen. Read the question thoroughly. A light ray passes from water to air and then to glass. In each case, state how does the speed of light changes. So the light passes from water to air. From water, you know the refractive index of water is 1.3 and to air the refractive index is 1. So ray of light traveling from denser medium to rarer medium. So when a ray of light traveling from denser medium to rarer medium, what happens? It bends away from the normal and it speeds up. Speed increases. Now in the second case, then water to glass. Water whose refractive index is 1.3 and glass whose refractive index is 1.5. Glass is obviously denser than water. When a ray of light traveling from water to glass, what happens? When a ray of light traveling from rarer medium to denser medium, it bends towards the normal and the speed decreases. So I can write speed decreases. Okay. So because glass is more denser than water. Clear? Okay. Now moving on to question number 12. A light ray passing from water to a medium speeds up and second medium it slows down. In each case, give one example of the medium and state whether the refractive index of the medium is equal to or less than or greater than the refractive index of water. So a light ray passing from water to a medium. Water to a medium. We don't know the medium. Okay. So water, the refractive index is 1.3. It is given, the condition is that it speeds up. So in order to speed up in the second medium, the medium must be rarer than water, right? So medium must be rarer than the water. So the medium can be air. So the medium can be air whose refractive index is less than that of water. The refractive index of the air is 1 and refractive index of the water is 1.3. Is it clear? Okay. And in second case, it slows down. In second case, it is slowing down. So ray of light traveling from water to any medium, it slows down. In order for the light to slow down, the medium must be denser. The medium must be denser, right? So the refractive index must be greater than that of water. So I can write glass. The medium must be glass whose refractive index is 1.5. Clear? So the second medium is glass whose refractive index is greater than water so that the light slows down. Clear? So I can name the medium glass whose refractive index is greater than that of water. Clear? Okay. Now moving on to question number 13. What do you understand by the statement the refractive index of glass is 1.5 for white light? So you have to express the meaning of the refractive index of glass is 1.5. So we know that the refractive index of glass, we can express it in terms of speed of light in air or vacuum, C divided by speed of light in given medium, that is in glass. Alright? Okay. So this is a relation for refractive index in terms of speed of light in vacuum and speed of light in given medium. So refractive index of the glass is 1.5. So I can write 1.5 is equal to C by speed of light in glass. So I can write C is equal to 1.5 times speed of light in glass. So it means the speed of light in air is 1.5 times the speed of light in glass. That's what meant by refractive index of the glass. Refractive index of the glass is equal to 1.5. What it is? I just repeat it. The speed of light in refractive index of glass is equal to 1.5. It means that the speed of light in air is 1.5 times the speed of light in given glass. All right, or the speed of light when light enters into glass, the speed of the light in glass is 1.5 times lesser than that of air. In that way also you can relate it. Clear? Okay. Question number 14. A monochromatic ray of light passes from air to glass. The wavelength of the light in air is lambda, the speed of light in air is c, and the speed of light in glass is v. If the refractive index of the glass is 1.5, write down the relationship between c and v. We know the refractive index is given as the ratio between speed of light in vacuum divided by speed of light in given medium. So the refractive index of the glass is given as 1.5, that's equal to c by speed of light in glass. Alright, so c, I can write it as 1.5 times speed of light in glass. So this is the relation between speed of light in air and speed of light in glass. Clear? Yes. And second part, write down the relationship between c and v and the wavelength of the light in glass. So refractive index can be expressed as the ratio between wavelength of the light in air divided by wavelength of the light in glass. Clear? So what we need? Wavelength of light in glass is equal to, I can write lambda air divided by the refractive index of glass is 1.5 divided by 1.5. So this is the relation. So lambda g is equal to lambda by 1.5. Is it clear? That means when the light enters into glass, the wavelength of the glass is wavelength of the light in glass is equal to 1.5 times less than the wavelength of light in air. So as you know that when a ray of light traveling from rarer medium to denser medium, or when it travels from air to glass, the wavelength decreases. How many times decreases? 1.5 times. So that's the relation. Is it clear? Okay. Now we will consider question number 15. Read the question number 15. In an experiment of finding refractive index of glass, the blue light is replaced by red light. Blue light is replaced by red light. How will the refractive index of glass change? Give reason in support of your answer. You know that the refractive index is inversely proportional to wavelength. More the wavelength, lesser will be the refractive index. So in this experiment, we have replaced blue light by red light. So what happened? For red light, the refractive index will decrease. You know, the red light has the maximum speed and the maximum wavelength, so the refractive index will decrease. So I can write mu decrease. And you have to give the reason. So what is the reason? In glass, the speed of red light is more than that of speed of blue light. So I can write that speed of red light is greater than speed of blue light in glass. So that's the reason. Clear? So remember, the refractive index is decreases with increase in wavelength. The more the wavelength, more will be the speed of light. Okay, so red light has the maximum speed and the maximum wavelength. So the refractive index for red will decrease for red light, and it will be less than that. It will be greater than refractive index will be less for red light than that of the blue light. Clear? Okay. Now question number 16. For which color of white light is the refractive index of transparent medium the least and the most? You know, for which color of white light the refractive index of the transparent medium is least. For the refractive index of red will be least, and refractive index for the violet will be maximum or the most. Clear? Yes. You know it, because the speed of or the wavelength of red is more than that of wavelength of the violet. Second part, which color of light ray travel faster in any medium except air? So which will have the maximum speed? The color which have the maximum wavelength. So I can write red. So red color of light travel fastest in any medium. Clear? Now coming to question number 17. Name two factors on which refractive index of a medium depends. state how does it depend on the factors stated by you. You have to remember two factors on which refractive index of a medium depends. What are that factors? You know that. Refractive index depends upon temperature. Depends upon temperature of the medium. How does it depends? Refractive index and temperature. As the temperature increases, refractive index decreases. You can write temperature and refractive index are inversely proportional. As the temperature increases, refractive index decreases. Clear? You have to remember it. And the second factor, the wavelength. Refractive index depends upon the wavelength of the light. How it depends? Refractive index and wavelength are inversely proportional. So you can say that the more the wavelength, lesser will be the refractive index. So as the wavelength increases, refractive index decreases. Clear? Okay. So that part is over. Now moving on to question number 18. How does the refractive index of a medium depend on the wavelength of the light used there? The same thing here discussed here. We have already discussed in question number 17. How does the refractive index? You can say the refractive index of the medium decreases with the increase in wavelength of the light. So I can write refractive index is inversely proportional to the wavelength. The more the wavelength, lesser will be the refractive index. Or we can say that refractive index of the medium decreases with increase in wavelength of the light. Clear? Now solving question number 19. Question number 19. How does the refractive index of a medium depend on its temperature? We have discussed already in question number 18 part. So this type of questions, conceptual questions, have got greater probability of being asked in the board examination. Practice this question which carries 1 mark each. So you know the refractive index decreases with increase in temperature. So the refractive index is inversely proportional to temperature. You can write the more the temperature, lesser will be the refractive index, or refractive index decreases with increase in temperature of the medium. Is it clear? So remember this key concept of the lessons which will help you to solve the questions. Clear? Now moving on to question number 20. What is question number 20? Light of a single color, a monochromatic light, is passed through a liquid having piece of glass suspended in it. On changing the temperature of the liquid, the particular temperature of the glass is not seen. So a liquid is filled in a beaker and a piece of glass is suspended in it. Piece of glass. So when you are increasing the temperature of the liquid, what happens? When you change the temperature, the refractive index of the liquid also changes. Refractive index of the liquid also changes. So at a particular value comes when the glass is not seen. So the glass piece is not seen when the refractive index of the liquid becomes is equal to refractive index of the glass. So I can write the glass piece is not seen when the refractive index of the glass become equal to refractive index of liquid, because you are changing the temperature. When you change the temperature, refractive index of the given medium also changes. Okay. Now question number 2. Why is the light of single color is used? It is mentioned that a light of single color, a monochromatic light is used there. Because you know that we will not, if you use a polychromatic light, we may not get the exact result. Light of a single color is used because the refractive index of the medium is different for different colors. So I can write refractive index of medium is different for different colors of light, or different wavelength of light. This is the second answer. Clear? So a single or a monochromatic light is used over there. If you use a polychromatic light, we may not get the exact result because refractive index of the medium is different for different colors of light. That's all for today. Practice all these questions. Conceptual questions, very easy questions. Easy if once you understand the concept, you can easily attempt those questions and score full marks. Thanks for watching.